I'm after something that illustrates your understanding, write it down and move on to the next one. Here's the topics that will be in the final exam. There will be 8 questions. Stakeholder requirements, specifically stakeholder requirements, not either the design requirements or detailed design requirements. Doing this all semester, the requirements we've been teaching you. These stakeholder requirements will be one full question with multiple parts. It's worth 20%. Hierarchy of control will also be one full question. Why? Why hierarchy of control, one full question? 4 weeks ago I went over to one of the dockyards in Garden Island. I went and spoke to one of the naval officers there, and on his whiteboard was his staff structure, and down the side was the hierarchy of controls. He'd been speaking to someone that he wanted elimination first, then substitution. He had the hierarchy of controls on his whiteboard. We're talking an officer of the Navy has that on his whiteboard. Okay? You are expected to design with that in mind. So we're going to run you through an exercise, see how you go. Fault tree analysis will be one full question. Ooh, you're going to love this one. Get into fault tree analysis, open up the notes, go through what we went briefly in the tutorial, but you will need to dig a bit deeper. Go back to the lecture notes, please, on that. Try and understand fault tree. For Mia, that will be one full question as well, worth 10%. Event tree analysis and bow tie diagram will also be one full question with multiple parts, so you've got a good chance of getting it right if you know a little bit about it and have a crack at answering it. I've got a question 4 which is in multiple parts that will cover probably this bulk of topics here, which is around duty of care, ALAR, certification, industrial design, design for assembly, design for manufacture, concurrent engineering, but I'll scatter those topics in amongst some of the other questions as well. But I won't be asking you the same question twice, I'll be asking you to decide from different aspects. So they'll be short written answers. There might be 5 parts to question 4. Each of them is worth 5 marks from memory. And each of them will be write me half a page to 1 page about that particular topic. What's the advantages and disadvantages? Where would you use it? Why would you use it? What's the advantage of it? What's the most important thing? What's the least important thing? Those sort of questions. If you sat through it, if you understood it, write down what your understanding is, you're probably going to get a lot more marks than you think. Now, critical, and I'm going to spend quite a few slides and a bit of time today talking about the case studies, because I'm going to ask you questions about the case studies, and it's worth 20%. There's 2.5 questions spread across, 2.5 questions and spread across the other questions. So there'll be 2 full questions on the case studies, and there'll be a smattering of case study issues as a subpart to some of the other questions. So I do need you to pick up the case study work and study it, please. So I'll go to tautology. Have a look through the lecture notes. If you've been working this in amongst everything else that busy people do, you appear here when you think you need to appear here. I understand that. Okay? Some people have got day jobs. Some people have got lots of full-time study to do, so you only appear here when you need to appear here. But I do need you to have had a look at the notes and quickly flick through and just pick the eyes out of it. Okay? I don't know why I've lost screen 2 over that side. Let's go and reselect it for you. That's better. Okay. There's Safe Design for Engineering resource pack, which lives in the centre part here on the screen from tutorial 6. Go back and have a look at that, right to the top, thanks. Go back to course materials, go and have a look at tutorial exercises and case studies. And around tutorial 6, we've got Safe Design for Engineering students. Clicked. That's what I need you to have a look and read through that. Okay, it explains hierarchy of control, it explains fault tree, it explains FMEA. By the way, the tutorial exercises we did come out of this document, so there's a bit of background material there. Flip your way through it, feel familiar with it. Okay? There's a case study material I've got on UTS Online. If I just go back and click on that screen there. Okay, I've given you overview of the case studies. Ford Pinto's there with all its detail. New York Skyscraper's there with all its detail, including the videos, if you want to have a look at those again. I would strongly recommend you review Ford Pinto and New York Skyscraper and the written material in it and the tutorial questions that you're asked in the tutorial, and be ready to answer those in the exam. I can't underline that enough. And every time I do that, people still give me blank answer books. So disappointed. Okay? There's tutorial exercises in the tutorials on event tree, fault tree, familiar, and hierarchy of control. And I've got a package of additional tutorial questions with answers and additional tutorial questions without answers. Okay? What I do not want you to study for the exam is on this list. We've already dealt with it. Okay? Don't study anything to do with Spark. Okay?
I can take a photo.
But also off the list are these things, because we've done enough of those in the development of your reports over the semester. I won't ask you anything about marketing. Again, we explored that in your C report and also in your customer survey. We've given marketing a good hammering. I won't ask you anything about project management. Let me spend a bit of time talking about what to study from the case studies and the guest lecture. There are 5 case studies, that's including the guest lecture I'd like you to know about. Okay? So I include the 2 video case studies that were done in the tutorials. New York Skyscraper, Ford Pinto. But also include the Harbour Bridge, Boeing 747, Toyota TRD, and I'm going to ask you some questions about Piper Alpha hazards. So just get your back out of Piper Alpha boats and have a look at potentially the website for that. Just familiarise yourself with the hazards there. It's easy. The sort of questions I'm going to ask about the case studies are already written out in front of you in the student notes template that I ask you to use to take down your notes during the case studies. Have a look at the topics there, look at the sub-points I've got in those, and I'll just get one of those and ask it back to you. But I want you to show some understanding. You took the notes, you were there writing it out. Have a look over the full set of questions in those student notes. Think about those case studies and see whether you can answer a question on any of those topics about any of the case studies, and you're fully prepared. I'd be only after half a page at the very most on each of those questions. I do need you to show understanding. So there's the sort of questions there. In particular, I want you to focus on these topic areas. Hint. This is all on UTS Online. Hint. I want you to do well, but I need it in your head and then I need you to write it down. So let's look at those case studies and I'll get this microphone where it actually works. That might be a bit better. Let's go through and say, well, specifically the Ford Pinto. I want you to look at engineering liability because that was what the Ford Pinto exercise was about. So where do I find Ford Pinto? I look at the reader materials supplied with the Ford Pinto exercise. So I've got some I prepared earlier. There is the Ford Pinto in the tutorial section that I've got here on UTS Online. But I've got some additional ones which is just a lift of that same material that I want to talk about today. It's under our lecture notes, under this particular lecture. Ford Pinto, Development of Auto Safety Regulations by, I think it's the New York, Matthew Lee, Department of Sociology and Criminal Justice, University of Delaware, wherever that is. Okay. As we suspected, it was far more complicated on the day. Ford was out there aggressively marketing a cheap car. It had some safety issues. But the regulator had got into the marketplace and said, to be safe, you need to go past this checklist of safety regulations. Well, that's ridiculous. That's absurd. That will never guarantee safety. But that was the environment that Ford Pinto was in. And it's this document that unfolds the environment and explains that that was the problem. Okay? What I've done is I've highlighted key areas of that for you. Okay, so it says at the top, the article about Mother Jones magazine said Ford Motor Company executives callously decided to reduce and continue to market the Ford Pinto, which they did, and that they had this cost justification was cheaper to let people burn. That's media hype, but they certainly didn't react and respond as a company today would react and respond. Okay? They stood behind the National Highway Transport Safety Authority, HTSA. So the NHTSA were starting to be labelled as the evil regulators that allowed this car to come forward. Okay? So, it says here, this NHTSA investigation didn't occur in a social vacuum. Here's the environment that was in. Now, according to Strickland, which is the Lee Strickland, the NHTSA engineer, I'll stumble over it every time. NHTSA's evaluation revealed that Pinto had a fire threshold, the speed at which the collision is likely to result in a fire in a rear collision between 30 to 35 miles per hour. Now, the rear impact test was set at 30, so at that lower threshold was unlikely to catch fire, therefore it's likely to pass. Okay? As it says there. So, there's still disagreement within the federal government as to whether law grants that company, the authority to hold cars with potential safety problems to a higher standard than the federal minimum. In other words, it had no legal authority to order the Pinto off the road. So, they concocted the famous video you saw. They concocted that. They put that together to show the public and create an outcry to say Ford Pinto was unsafe. So this is what they did. Okay? They wanted to prove that Ford Pinto was unsafe, so what they did is they put together a crash test. They selected a large and particularly rigid car as the bullet car, the one from behind, rather than a moving barrier, which is the way the test is normally, so people could actually see a car in this footage. They set the cameras up and they ran and they ran and they ran this test until finally it caught fire. Okay? Both the Pinto and the bullet car gas tanks were full with petrol rather than non-flammable liquid normally used. The nose of the bullet car was weighted down so it would slide under the Pinto. Okay? The bullet car's headlights were also turned on to provide a ready source of ignition. And after several crash tests, they got that famous video. We've all been had, haven't we? Okay, and the whole idea was to force Ford to voluntarily recall its car because NHTSA had got it wrong by regulating the industry with standards rather than with true safety. Got it? Have a look through the highlights and you'll be surprised. Okay, have a look at that one, please. Get that idea in your head. The Citicorp Centre. Let's have a look at that one. I put together this, it's my cut and paste out of various articles. I went back to the New York Times article where this was originally exposed 20 years after the drama. And I then looked through all the references I could about what was happening on the day, till finally at the end of the document I've got what seemed to be the inside thinking of the company and what was happening in the boardroom at the time. Okay? So we know that Le Monsieur was not overly concerned because the original design for the safety factor for that building was 1:2. So it was designed at double the load level for that particular building. What it turns out to be is the New York code had a type error in it, type as in physically typed out wrong. Instead of showing it legally as 1:2, it has 1.2 in the safety factors. So was only 20% stronger than the design minimum was required as a safety factor, rather than 100% stronger. This was never discovered till after the article went to press. Okay, this is here. Meant the building was in critical danger. Yep, so that's why he found himself there, because people said, oh, no, it needs to be 1.2. Doesn't need to be 1:2. Okay? So at the end, what Le Monsieur did wasn't the noble deed. He negotiated commercially with his commercial masters. Say, we designed, we stuffed up, can we negotiate our damages so my company doesn't go under? And in a boardroom discussion, probably a very heated one, to say it politely, he managed to deal with severe and potentially catastrophic problems and weakness in the joints. He accepted possible loss of professional reputation, etc. But the liability insurers had previously agreed to underwrite a figure that turned out to be only a fraction of what the cost became. If Le Monsieur's consulting engineers were obliged to carry the difference, we talked about that in one of the lectures, they faced financial ruin. So negotiations at the senior level between all three parties resulted in the costs being borne by the insurers and Citicorp only, with no financial blame attached to Le Monsieur. I'll pose the question, why was this not revealed for 20 years? That reason, commercial confidentiality, was hidden because he agreed not only that they would carry the damages, but he would not speak out. And it wasn't until it was publicly disclosed that under the standard non-disclosure agreement, now in public domain, he could speak out. What a poison chalice that became. And I'm glad the building didn't blow over. Okay, so I've got a commercial view, I've got an engineering view on this that says that was some of the framework that prevented Le Monsieur speaking out. Why would that matter? It does matter. It does matter, it's a big deal. It matters because of this. Main pillar of Newcastle Workers Club exploded. Okay, see the building? Where the car park underneath is let go, the building's collapsed under the weight of the car park pillars being lost and the building's gone down.